Okay, hello students. Today I'm going to model how to model annual temperature fluctuation into trigonometric functions. So the chart is showing you is from the information that is given to us in this data. This data shows an average high temperature in degrees in Fahrenheit for Barrow, Alaska are given, and starts from the January. You can see the x-axis begins with the January. One stands for the January, then February, March, April, May, June, July, August. And they did give us these points, and I try to join them, but I don't want to. The information data is given right here as which month, what was the average high temperature is given. And I just want to mark those points. What I'm going to do first thing is do manually put this into data into the desmos activity where we can make a x-axis and the y-axis and figure out what's going on. So the first thing is, so even though this graph is showing you, but still I would like to put this whole information into the desmos to see clearly what's happening. Our goal is to create a trigonometric function a sine b x minus h plus k, where k stands for the midline, h is the horizontal shift, b is the period, and a is the amplitude. So the amplitude, the formula will be maximum minus minimum divided by 2, but you have to take the absolute value. And the period is 2 pi, because 2 pi is the period of the sine function, and t is the this b is whatever the period that we see, the cycle that completes. And then the horizontal shift is where we will see where should be started. And the vertical shift is maximum plus minimum divided by 2 equals a. Okay, let's go directly to the, so I'm gonna go to desmos activity right here, I think. Not this one, not this one. I think I used, okay, here it is. So what I did was the same data in January till 12, in December, I placed them here. This is in case if anybody wants to know how you do it, is you just open the desmos.com. And in the desmos.com, click on the graphing calculator, and then you see those 3 dash there. Click on those 3 dash, scroll down all the way until you get linear statistics, linear regression. So actually this has to even figure out create polynomials of different degrees. So right now we are in the sine. So this is how it starts. So whatever this 1, 2, 3 and the data, whichever the number, just plug in those 45, all those numbers. So you put 1 to 12 and then plug those in. The rest we will see the one that I already created. So in this case, I already put the numbers. January is minus 7.4, February is negative 11.8 Fahrenheit, and so on. So all this data is put until 12 months. So once I do this, I click on this. By default, it will be always showing x1, y1. So let me click on this, and you see all those dots. Let me use these dots as purple color so that you can see. And these are all the spread of the data. Now, looks like nice graph. So what I'm going to do is first is make it like a manual graph and see what is the midline or what is the maximum minimum. The first thing is by knowing this, at least we know the maximum. See, this graph goes this way, increases, then takes a turn and goes down, and so on. So what I will do here is first find what is the maximum, and you can see from the data there. Step number 1, I'm going to figure out what is the amplitude. Let's find the midline first. So to figure out the midline, so the midline is the vertical shift is maximum plus minimum divided by 2. So do I have enough room here? So the maximum is 48. Yeah, the maximum is 38. Yeah, 45. So let's find out. the K is maximum plus minimum divided by 2, and maximum was 45. So 45 plus the minimum was negative 11.8, and then divide by 2, and if you work this out, you will get 28.4. That's the K values. Then we also, this is the midline. Then also let's figure out what is the amplitude. So the basically what this means is that 28.4. Now this is 20, and this will be around 30. This will be 15. So the midline will be. I'm so sorry. This is 16 point. So this is 16.7. You can check this with the calculator. So 16.4 will basically means I have to draw a line. So 16.4. This is 15, then 16, then 17, then 18. Oh, sorry, 15. This is 20. This will be 25, and this will be 5, 10, 15, little above. So I have to draw 15, 16 will be this one. So this is not, this is all approximate. Approximately I'm graphing. So this is the line. The K, Y is 16.7. And now I'm gonna use a red graph to see if I can, the maximum is right here. This is the maximum I'm taking. That's the minimum. And the amplitude, so what is that amplitude is, we have to figure out what is the amplitude, which is A, and that is absolute value of maximum. This time you do subtract, divide by 2, maximum is 45, minus 11.8. And you work this out, you should get 20.4, yes, so that's 20.4. So this is how far is the maximum from the midline. So that means if this is maximum, this is that 28.4. Now, once you know the minimum and the maximum, let me graph this. Now this is not going to be a perfect graph, but just want to show that this is how it goes. The temperature increases very fast here. At some point, it's going to change from increasing. So you can see there is a kind of an inflection point where the temperature slows down. And then again, at some point here, it is increasing very fast, but then again, it slows down, and so on. So this is the graph of sine. My goal is to figure out, we did get the K, we did get the A amplitude, so that's the amplitude. We also need to know what is the, where do I begin here? Okay, so a lot of options here. I would start with the one that's this point. Look at this point. Let's take this as the point because this is the manual part. So if this is 4 and 5, so this will be 6, this will be 5, around 5, this is like 4.5, right? This is 4.5. So that means I can think of a sine graph beginning from this point and this way. So that means if I had a graph starting from this way and it has shifted to let's 4.5, I can think of H as, you can think of H as 4.5. Okay? So I use 4.5 as the horizontal shift. So, and then, so what are the things we needed? The B part. So what is this B part? So we did know now what is the H. This is the horizontal. That's the amplitude. Amplitude is always positive. How far is the maximum from the midline y equals 16.7. Now, last part is to figure out the because this is 12 months, the cycle continues every 12 months. That's what the data tells. So because it is from 0 to 12, so this cycle again continues. So we will use that V part. Look at that. So V is, so do I have enough room here? Let me take it. So B is 2 pi divided by 12, which is pi by 6. So which is also can be written as 3.14, and if you divide this, you get 1.57, right? So you get 1.57. So that's the B part. So the cycle is, the period is 12 months, but we need to know what is that B to replace here. So your answer will be now, let's write down y equals, so the temperature, average temperature, T in terms of months, maybe M stands for the month. I can start from this as the mean point 4.5, and this is 16.7. So the amplitude is 28.4, 20 sine of the B is 16.7, x minus, I'm going to use x as the months, let's use this, x minus 4.5, and then put plus, it shifts 16.7. I made a mistake here, this should be 1 point, B is 1.57. See, beautiful equation. So this is manual way to figure out, knowing the data, we can do this. Now some of you will say, why can't we start from here? We could have started from here, but if we start from this point, then you have to be careful, right, that this graph starts from down, goes this way, kind of a reflection of the cosine graph. Because the cosine graph starts from top down, but this starts from bottom up. We could change this same formula, and if you want to start from this end, then start from down, so you have to take minus 28.4. Everything stays the same, except the where are you shifting? You're shifting at 2, so this point is 2, this point is 2. So minus 2 and plus the midline stays the same, which is 4.5. So H is 16.7. There you go. So that could be also answer. Or you could also start from this end. So if you start from this end, you have to think of what is this? That's 7, right? So we can also write this as another equation. So this is one when you're starting, the main one. This is if you start from this point. This is if you start from this point. I can write another equation here and write down Tx equals 28.4 is the amplitude, then sine of 1.57, and this time it will be x minus 7, and then plus 16.7. So different ways to write the equation. Now let us see what did the desmos do. So we have an inbuilt software where directly we get the answers. I'll take this off and show you how to figure out from the. So this is manual to get whatever the information data was there. We try to create a trigonometric function sign, and as I said, we get. There's one mistake I think I created was because this was a reflection. This should be cosine. I made a mistake here. This should be cosine here. So because if you start from here, it goes from down this way. So it is a reflection of the cosine graph. So, and if you start from here, this should be the sine. I'm so sorry about this cosine line. Now, get back to the trigonometric, and I'll go all the way down. So this one, I try to write this as, okay, let's see what does the desmos do is I put a sine, the same thing, and what it does is, by default we get the answer, and I click here, and you can see the graph shows a different graph, but almost close to it. What did the graph gives is 28, this is exactly the right answer, 28.5, and we got 28.4, so there is a difference of 0.1. B was 0.57, so the B part was, yeah, it should be 0.5, I think I messed up here. So B is, it was 2 pi divided by, remember B is 2 pi divided by 12, and this was 6 here, and by mistake I divided by 2. This is wrong. This should be, if you divide this 3.14 by 6, you get 0.52. So I'm going to change it 0.52. So all this will be 0.52. So this is 0.52, and this also will be 0.52. Okay, so I divided by 2 and I got it like 1.1. Okay, and finally we have H. H is 4.6. H was, we got is 4.5. So 4.6 will be somewhere maybe here. So this part, this is, so the one that I took was to the left, but this one is to the right. And finally K is 17, and we got it at 16.17. So this K is 17, which is a little higher. I took it a little lower, maybe a little up. So the goal is, what did we learn from this is, from the information data about the temperature, high temperature in the city, we can always model into a trigonometric function, f of x, a sine, or it could be a cosine. And depending on that, you have to figure out how midline, then you have to see the maximum, minimum, find the midline, and also see the horizontal shift and the vertical shift. And that's it. And the B, main thing is the period, how to find that B equals. And once you get that information, plug it in and you get the answer. That's all it is. So two different ways. One is you do manually, like how I did in the beginning. And the second one, the built-in software in the desmos already does it for you. You don't have to break your head. And at the end, I want to know, okay, here it is at y equals 17. I just wanted to click there. You got that. So this is how you're supposed to complete the problem. And yeah, this was the one that the problem that I got. I think this one. Yeah, that's what I wanted to show. Hope that takes care. The next problem, another problem I'm going to do is on how to figure out how to model the height at different places on the Ferris wheel. So we will see one problem on Ferris wheel. If you are starting point here and you're moving, and in some seconds you get back to the same thing, how the heights are changing. So I will create a model based on this. Okay, stay tuned. Thank you for watching. And yeah, as I say, I always love to show why maths can be used in the real life situation. What is the whole goal of learning about trigonometric functions, sine, cosine, tan, cosecant, secant, and cot? There has to be some reason, and you can see it is applied in this high temperatures. It could be the population of a city, it could be height of this one, or it could be movement of the forest or temperature, or it could be anything about even the population of mice or rabbits or a pendulum moving. So if there is a pendulum, I can keep it at some distance and leave it. It will move up and down, how far away and coming closer. we can model that also. So this is the first problem. Very soon I'll do the second one. Thank you.